Now, our next session, we're going to be learning about building cool Windows apps with the Windows Apps SDK. And I want to bring on Deanne here to kick off the session. How you doing?
I'm doing well. How about you?
Oh my gosh, it's a great day at .NET Conf. What are we going to learn about today? What do you want to do?
Well, before we go there, I'm going to reintroduce myself. My name's Deanne Hartono. I'm a program manager on the Windows Developer and Experiences team. I'm here along with my awesome coworkers to talk to you all about Windows App SDK and specifically the release of 1.0. It's here. Well, it's here next week. So that's such a great moment. It's a time to celebration, like clap, clap, snap, snaps, all of those things. And so one of the reasons why we built the Windows App SDK is to break down the barrier between UWP apps and classic desktop apps. So what does that really mean, right? And so if you were a developer who was developing for UWP, you may not have access to the classical desktop APIs in order for you to achieve the scenarios you want to achieve. And then if you were a desktop app developer, you couldn't leverage the modern UI and cool features that we've been developing for UWP. And so you're a bit of a pickle, right? And so that's where Windows App SDK comes in. This is a new technology. We're creating a common app platform that is more modern, open, and productive. And so I just said a lot of things, but I also want to mention that Windows App SDK works really well with your developer tools. So, for example, it works great with Winget, and it works right out of the box with Visual Studio 2022. And for those of you who do ARM development, you're in luck. A Windows App SDK makes your app run super fast on ARM devices. And for those of you who are doing web development, you're also in luck. Windows App SDK along with WinUI 3 makes your app, your native web app, run smoothly. And so with that, I am going to hand it over to my awesome Windows App SDK panelists and teammates. And we're going to first start off with Marissa, who's going to talk to us about WinUI 3. Marissa?
Yeah, thanks, Deanne. So with WinUI 2, it's a lightweight, flexible controls and styles library that works great for UWP. But with WinUI 3, we wanted it to work effortlessly with desktop apps as well. WinUI 3 is the full-fledged end-to-end UI framework of the Windows App SDK. It gives you the latest graphical capabilities while being completely decoupled from the OS. Now, along with WinUI 2, WinUI 3 has made it easy for you to adopt the Windows 11 look and feel. I want to show you some of the new styles that we've added and how you can get it for free without needing to add any code. And I did a recording that I'm going to show you now. So Deanne, if you could play the video. So on the left, I have an older version of the app that's running with the old styles. And on the right, I have the new version running 1.0 of the Windows App SDK. We've updated all of the controls to have rounded geometry. And you can see some of that here in the buttons that the ebooks are in, and even in the scroll bar over on the far right. And I'll show you what the scroll bar looked like in the old version so you can see the big difference that we've made. We've also updated all of the text in the controls to include the system text font of Windows 11 called Sego UI variable font. We've even updated the iconography for all of the controls to include the system icon font called Sego Fluent Font. Speaking of icons, we've even added some fun micro animations to some of our controls. And you can see that here in the navigation view when I hover over the hamburger button, and you can see the old one on the left-hand side. It does not animate, not as fun. And there's even my personal favorite, the settings gear. And I actually want to go to the settings page of this app and flip this app to dark mode so you can see the coloring differences and how great this app looks. The new styles look awesome. And you can even see on this page there are a couple more examples of the rounded corners on the buttons, and the selected state of the radio buttons has a new fun animation as well. This app is even using WebView 2. And when you open the book, you can see that it works seamlessly with this WinUI app, and the performance is great. WinUI 3, this app overall looks great, and it fits in seamlessly with the Windows 11 look and feel. Now, along with updating the styles, WinUI 3 has made it so you can use whatever packaging and installer technology you'd like. And I actually want to show you an example of this using a WinUI 3 app from the command line. So I'll show you this in my next video. So this is the same .NET ebook reader app that I'm going to run from the command line. And I'm going to go to the app folder. And you can see that there's just a straight executable here. I'm going to run that executable. And the app just launched. It just runs the standard Win32 process like other Win32-based apps. And you can really call any Win32 API like you were doing with other technologies like MFC, WPF, and WinForms. Now, I want to run this app again, but this time I want to open a book from my ebook library that I have on disk at the root of my hard drive. And I'm feeling like reading a fantasy book, so I'm going to open Peter Pan. So I'm going to navigate to my ebooks collection and open the ebook Peter Pan. Now you can see that when this launched, a second instance of the same app is opened. .NET apps, by default, are multi-instance. Now I could make this a packaged app if I wanted using MSIX, or I could use a different installer technology like MSI. The great thing about the Windows App SDK is I can use whatever packaging and installer technology that I want. For new apps that want that fresh, modern UI using WinUI 3, you can use the Windows App SDK with .NET and C++ Win32 apps and have full access to the depth of Windows APIs. And for existing apps like WPF and WinForms, you can take advantage of the non-UI capabilities in the Windows App SDK. That includes things like the application lifecycling events, windowing, and MRT core. Now later on in this demo, Adam and Andrew are going to go into more detail about the instancing APIs and the deployment options you have for your apps. Deanne, I'm really looking forward to the rest of this talk.
Oh, same with me. And a great job on showing us all the cool things, especially dark mode. It's my favorite feature on Windows 11. So speaking about Windows 11, I'm going to have Eve take it away to talk to us about how Windows App SDK will help developers with Windows UI and UX guidance. Eve, take it away.
Thanks, Deanne. I'm excited to show you what's possible on the Windows App SDK windowing platform. We built this platform with all developers in mind. So whether you're working with WPF, WinForms, or the latest WinUI framework, whatever framework you're on, you can use these APIs to extend your windowing capabilities. We've been listening to feedback. We know it's hard for you to build out common windowing tasks. And on the user side of things, we know how important consistency is in how they can expect windowing behavior. And so we've made it significantly easier for you to build windowing experiences that align with Windows design. So for example, we've prepackaged windowing experiences like full screen and compact overlay. They're not exactly new features, but there's now a platform-approved way of building out these features, as opposed to having you roll out your own versions or implementations of the same. I have a demo prepped. Deanne, I think we can play the first demo to show how this works. So here I created a video player app. I used WPF to do this. And it's pretty simple. I have two buttons here at the bottom that allow me to toggle between my full screen mode and back, as well as the compact overlay experience as well. The window becomes smaller and it's always topmost. I especially like it because I can multitask and do other things as I continue working on watching the video. Now, how I achieved this using Windows App SDK is quite straightforward. Here in my main window constructor method, I obtain the app window object from my top-level WPF window. I use the interrupt APIs to do this. Now, armed with that app window object, I can then call the setPresenter API. And as you can see here in my toggle function, I can switch between the default presenter kind and the compact overlay presenter kind. And I do the same exact thing with the full screen experience. I don't have to worry about making the window topmost or making sure that it's full screen. The platform takes care of that for me. And again, this is not exactly new features. It's the platform. You now have a platform-approved way of building out these experiences. That means less work for you and more consistency for our shared user base. Now, let's switch gears a little bit and talk about windowing design. Deanne, I think we can show the next one.
Now let's talk about the
Now,
window frame.
you know how important it is for you to
Windows
build
does
out
provide
your
a
windows
default
to
title
match
bar.
your design, to match your brand. The system does provide a default experience. It does provide you a default title bar. But we know how hard it is for you to customize this because we actually don't support it. But that's changing. So say, for example, I wanted to make the color blue in my title bar, or add a favorite button in my custom, in the title bar area. If I had to do that with what the platform offers today, I have to tell the platform to stop drawing the default one and draw my own. I have to redraw everything from the icon text, including the caption buttons as well. But that is already expensive work. But what's more, you end up missing out on some really cool Windows design features that we are making. So for example, rounded corners. My app isn't rounded because I got rid of the border. And when I hover over the maximize button, the snapshot menu doesn't show up, which is a really cool Windows 11 feature we rolled out. So now I'm going to show you how I can achieve the same design with Windows App SDK. So we're going to look at the code behind this and show you how that works in action. Let's quickly go through this. I have a function called the draw custom title bar. And the first thing I do is just make sure that I can actually run some customizations on the release that I'm running on. And then the next line is I set the property extends content into title bar to true. This tells the platform, hey, stop drawing the system version of the title bar and let me roll it out on my own. But it comes with even more support, as you'll see. I then make sure that my UI element that I defined is visible, the my title bar the my title bar UI element. And then, and this is a very important part, the system will continue to draw the min, max, and close buttons for you, but you get to style them. You get to determine how they look. And that's what happens in that bunch of code right there. Then there's also, you want to make sure that your title bar height, as you've defined it, matches up with what the system is providing in terms of the caption buttons. That's the min, max, and close buttons. And the last bit I do here is I set the drag regions for my title bar. That's very important because you have to ensure your window is movable. So in summary, what's happening here is we provide you with information about where the system is drawing the caption buttons. And you can draw around it and make sure that there isn't interactive content in that area. And we also provide an API, set drag rectangles, for you to define areas in your title bar area that should be draggable. In summary, our approach is to provide more support to build this core windowing functionality. And as you can see, when I run this app, I achieved the same vision I had in terms of color and functionality in my title bar, but the platform makes it a lot easier to do that. Now, Windows is always evolving, and if you are rolling out your own custom frame, it's expensive to do so, and in some ways you also miss out on some key and cool features that we're building out. With Windows App SDK, we've made that a lot easier, and we're constantly evolving it. And as Deanne said, you can try these APIs out as soon as the V1 release comes out.
Brilliant. Thank you so much. And I gotta say, I also agree. The rounded corners really make a difference. And so, can you tell us a little bit more, perhaps, about the windowing roadmap?
Oh yeah, sure. So again, V1 is just the beginning. We have a lot planned down the road, and we value your feedback in how we build this. So one of the things that we're thinking about making sure, making sure we're doing is that we can have even deeper integration of this Windows App SDK APIs with the UI frameworks that you're using today so that you can easily adopt it into your apps.
Excellent. All right. So up next, I've got Andrew, who's going to be talking to us about app lifecycle and power state. Andrew?
Yes, thanks, Dan. Yep, I'm going to talk about the app lifecycle features in the Windows App SDK. And they fall into 3 buckets, I guess. Activation, which provides APIs where your app can tell the system what kind of activations it wants to support and to get the activation event args when it does get activated. Second, instancing, where your app can decide whether it wants to be single-instanced or multi-instanced, or control the number of instances, and potentially even control the sort of work that each instance is doing. And thirdly, state notifications, which provide your app with the APIs it needs in order to make informed decisions about the kinds of workloads that it wants to execute under different circumstances. So I have a couple of demos. Diane, if you want to play the first video. Great. This is a WinForms app. As you can see, I've set some arbitrary command line arguments. When I execute the app, it's old school UI. I'm getting activation kind launch, and I'm getting the activation event args, which I'm just printing out. If we look at the code in main, it's very simple. I'm just calling get activated event args, figuring out the kind of activation it is, grabbing the payload, the activation event args, and just doing whatever I'm going to do with those. Also, you can see I've got a bunch of WFE files, and this app is going to register file type association for WFE files. And you can see I can do this dynamically. I can register, I can unregister, so that there is an association between those files and this app. And again, back in the code, the registration is very simple. I just register one or more file type extensions, and when I unregister whichever file type extensions I want. So what happens if I double-click one of these files? You can see I get a fresh instance of the app, but this time the activation kind is file, and I get different payload, including the file name, obviously, and I can open that file. And every time I try and open a new file, I get a new instance. So you can see now I've got 4 instances running. If I try to open a file that I've already got open, it doesn't give me another instance. Instead, it redirects that activation to the instance that's already got that file open. And I can do this as often as I like. You can see I'm just calling into the onActivated in the instance that has that file open. So I still only have 4 copies of the app open. And the code for this, again, back in main, I get my activated event args. I figure out I want file activation. I get the file out of the event args payload. And then I register the file name for this instance. And I get an instance back. And if that instance is this current instance, it means that I've got the file open and nobody else has got the file open. So I then hook up my activated event so that subsequent activations come into here. If we look at that, that's pretty simple. I'm just bringing my window to the foreground and printing out some information on the screen. But if, when I register the file name, if I get a different instance coming back, it means that some other instance had that file open. So what I do then is I redirect this activation to that other instance, which will cause that other instance's activated handler to be invoked. And one other thing we can do is that the APIs also let you get information about all of your running instances. So I have another button there in the toolbar. You can see I've got 4 instances running, and I'm getting information about them, like the key that they registered, if they registered a key, the process ID, and other information. And again, the code for that is extremely simple. I just call get instances to get me a list of the running instances of my app. Okay, so that's activation and instancing. The third piece is power and state notifications. I have a different demo for this, Diane. It's a very simple demo. This one is a WPF app. Again, old school UI here deliberately. I've just got a couple of buttons in the toolbar. I can register and unregister. And I'm registering for event notifications for things like the battery state, the power state, the display state, and so on. And there in the middle, you can't see, but I actually pulled the plug so that I get a different set of events coming in. And then I put the plug back in, and I get another set of events. The code, again, is very simple. You can register or unregister dynamically for these events. So the registration is a simple matter of hooking up delegates to any of the events that you're interested in. And unregistering obviously just unhooks those delegates. And when I get one of these events, I just look at the state. So what is the battery state right now? What is the power state? What is the display state? And so on. And I can use that information to make sensible decisions, like if the battery's in a poor state and I'm on battery power and it's not charging, then I probably shouldn't be doing any non-critical work. Or conversely, if I'm on AC and the battery's good, maybe I can do some resource-intensive work. And similarly, if the screen is off, well, there's no point updating my foreground UI, so I could go and do some background work instead. And that's pretty much it. So activation, instancing, and state notifications, they're all ways that you can control your app's own lifecycle.
That's brilliant, Andrew. Thank you so much. And so I did notice something in your demo. I noticed WinForms as well as a WPF app. What about desktop apps?
Yeah, these APIs can be used in pretty much any app, WPF, WinForms, Win32, classic WinMain apps, console apps, WinUI apps, pretty much anything except UWP because the features are coming largely from UWP, so UWP can do these things anyway in the platform. But the APIs in the Windows App SDK can be used in all other app types.
Cool. I just love seeing the magic of Windows App SDK. And so last, but certainly not least, because it is my favorite topic because I work on it, Adam is going to be talking to us about deployment. So Adam?
Hello, Deanne. I'm excited to share with you how we've enabled the Windows App SDK to work with all application types. The Windows App SDK is built on top of MSIX technology. MSIX provides your customers a clean install and uninstall experience, and for developers, it frees them up from having to build their own custom installers. However, previously, all the APIs in an MSIX framework package were only available to other MSIX packages. Well, now we've broken that barrier and enabled all applications to use the Windows App SDK. That means your apps, whether deployed with MSI, setup.exe, or even Xcopy, can now take advantage of all what the Windows App SDK has to offer. Let's take a closer look. Go ahead and start the video. Here I have a simple WPF app that calls a few Windows APIs to get a system device ID and information about the display monitor. Now, earlier we saw Andrew show off some new Power APIs. Let me demonstrate how easy it is to add that functionality to this existing app. First, we add the NuGet package reference. This will enable me to call those APIs. In this case, I'll add calls to the Power Manager's display status and energy saver status APIs. Those will be fine additions to my app. Now, I need to add the Windows package type property to my project and set it to none. This is a new property that informs the build that the application is not packaged with MSIX, and to generate logic that initializes that access to the runtime when the app is launched. However, before I start the app, as with any Win32 app, it is the developer's responsibility to ensure all dependencies are deployed. Here we provide an installer that deploys all those dependencies for you, making it super easy to incorporate into your own setup application. Now let's go ahead and run the app and see it in action. Behind the scenes, the Windows App SDK is using module initializers to bootstrap the logic for loading the Windows runtime and making it available to the app. Once initialized, all API calls are found inside the framework package. Here you see that our call to Power Manager succeeded. And now I want to prove that there is no smoke and mirrors here. Recall that recently sysinternals celebrated its 25th anniversary. And with that, the suite was published to the store, so it is super easy to find and use your favorite tool set. If I bring up Process Explorer, we can see that the application has no identity in the package column. And if I scroll down, we can see that the Windows App Runtime is being loaded from the framework package directory. proving that regular apps can use the Windows App Runtime Framework package. And so, Deanne, do you have any existing apps you want to update?
I do. I have a list of them. Gosh, Adam, you're making me work here. So how about WinUI apps? Would they be in this model as well?
Yes. As Marissa showed earlier, it also works for WinUI itself. The WinUI templates currently default to a packaged MSIX application. Let's go ahead and flip back to the video. All right, so for WinUI apps, it's just as easy to switch over to your own deployment model. The key is the Enable MSIX Tooling project property. This property tells our VS extension to build an MSIX package. This enables the deploy option in the debug configuration settings, and it also recognizes the package.appx manifest as a special project type. If we turn off this property, it'll disable that logic. Note that the deploy option is no longer enabled and that the package manifest is no longer recognized as a special project type. Now, when we go back and set Windows package type equals none, like I showed you earlier, that'll auto-initialize loading of the framework. However, before I F5, notice in the Start menu there is a new debug target. This debug target allows you to switch between launching a packaged app or a regular desktop application. Make sure you choose the unpackaged option. So when I start this up, there you go. We've taken a WinUI app and moved it over to work without MSIX packaging. Essentially, all you need to do is update a couple of project properties. And so, Deanne, back to you.
Thanks so much, everyone. Well, there you have it, folks. We've shown you some, not all, features of Windows App SDK. Now, we did focus on Windows 11, which looks brilliant, but it also, Windows App SDK also works down level as Windows 10 1809. And with that, I also want to mention, if you are ready, and obviously you are, ready to learn more about the Windows App SDK, visit our website at aka.ms/WinAppSDK. And with that, I'm off. I'm going to invite Jeff back to the stage to take it over because, yeah.
Thanks so much, Deanne. Hey, why don't we keep you here? We got a bunch of questions from folks in the community. I think you can help me out here. So there's a couple of them here. This one from Daniel, and maybe some folks from the panel can help with this. Can we make Windows App SDK .NET single file applications? Is that something we can do? Because right, with .NET we can make single file, we can compress everything together. Can we do that with Windows apps?
Currently we're working on that. That's part of our roadmap, is to publish single file applications. It's currently not in there for 1.0, that's on the future roadmap.
Okay, wait, speaking of the roadmap, actually, Deanne, you pointed this one out. Do we have a final date for the Windows app?
I do, and I was supposed to mention it. It's going to be out, released next week on 11th, 16th, at least as of like today. So, yeah.
There you go, breaking news. Oh my gosh. Thank you so much. Thank you, panel. It was great having you here with us for .NET Conf, learning more about building apps with the Windows App SDK. Love it. All right. Now, I want to make sure we call out, there's all kinds of stuff for you to be doing on that .NETconf.net website. Make sure you go there and check out all the cool things going on, including information about the local events, both in person and virtual. There's more than 69 of them around the world. There's bound to be something local to you. I want you to check it out and go connect with those folks at your local events.